Hello students, let us read the question. The captain of the plane wishes to proceed due west. The cruising speed of the plane is 245 meter per second relative to the air. A weather report indicates that 38 meter per second wind is blowing from the south to the north. In what directions, measured with respect to the due west, should the pilot head the plane relative to the air? So, the key concept involved in the question is the relative motion. Let us suppose this is object A, which is moving with a velocity Va with respect to the ground, and this is object B, which is moving with a velocity Vb with respect to the ground. So we can write the velocity of A with respect to the B is equal to velocity of A with respect to ground minus velocity of B with respect to ground. Here in the question, for this question, we can write the velocity of plane with respect to the air is equal to velocity of plane with respect to the ground minus velocity of air with respect to ground. This is the formula that we are going to use to solve the question. And the next key concept is about the direction representation on the Cartesian plane. Let us suppose this is the Cartesian plane, standard Cartesian plane of the x and y plane. Here we are going to represent north direction in the positive y direction. This is south in the negative y direction. This is east and this is west. Now let us read the question. In the question we have been given the velocity of plane with respect to the air. Velocity of plane with respect to the air is equal to 245 meter per second. We don't know the direction, and the weather report indicates that 38 meter per second wind is blowing from south to the north. So we can write the velocity of air with respect to the ground is equal to 38 meter per second, and the direction is from south to the north, so it can be represented by j cap. Now let us use the formula here. The velocity of air with respect to the ground. This is the velocity of air with respect to the ground. It is in the positive j cap direction. And the velocity of plane with respect to the ground given in the question itself, the captain of the plane wishes to proceed due west. So it can be represented by minus I cap direction. Now we need to find out the direction of velocity of plane with respect to the air. Here this is the velocity of air with respect to the ground. This is the velocity of plane with respect to the ground. If we do some vector modification, we can write this vector as minus VAG. This is the vector, and now we need to find out VPA equal to VPG plus minus VAG. If we add these two vectors, the resultant should be in this direction only, that is between west and south. So we need to find out what will be the angle with the west. So let us redraw it in a triangular form. This is VPG. This is the velocity of plane with respect to the ground. This is minus velocity of air with respect to the ground. And the resultant will be the velocity of plane with respect to the air. Now we need to find out the theta. For the plane to proceed in the west direction, velocity of plane with respect to the ground should be equal to velocity of plane with respect to air cos theta. Similarly, the velocity of air with respect to the ground should be equal to velocity of plane with respect to the air into sin theta. These are the equation to proceed the plane in the westward direction, that is the westward direction. From here we can calculate the value of sin theta. Sin theta can be written as sin theta is equal to velocity of air with respect to the ground's magnitude upon velocity of plane with respect to the air's magnitude. Now let us put these values. We know the sin theta is equal to 38 upon 245. So from here the theta is equal to sine inverse 38 upon 245. This value of theta is equal to 8.92 degree. This is our answer. So here the option C is correct, that is the south of west. So our final answer is option C, which is 8.92 degree south of west. Thank you so much.